Okay, this is just a quick video on D2, trig functions and transformations in grade 11 math. So if we just look at a graph of y equals sine x with no transformations, just a straight graph of y equals sine x, if you recall our unit circle, this guy with 0, 90, 180, 270, and then back to 360, we can actually pull off all our values of sine x from that, or you can use a calculator. Okay, so I've got here 0, 90, 180, 270, and 360. So when I calculate what sine of those angles equal, I get 0, 1, 0, negative 1, and 0. So if I were to plot that on a graph, let's say that's 1 and negative 1, then my graph starts at 0, 0, goes through 90 and 1, 180 and 0, 270 and negative 1, and then back to 360 and 0. So that's what one cycle of my sine curve looks like, and then it's going to keep following that pattern over and over again. So if we had to describe this graph, we'd call it an amplitude of 1, which is the distance from the maximum to the middle of the graph, so that's 1 unit, or from the middle of the graph to the minimum, 1 unit. So that's our amplitude. The period of this graph we would say is 360 degrees, because it takes exactly 360 degrees to complete one full cycle of the graph. And we have something called the equation of axis, which is the line that goes right through the middle of your graph. And that's happening right at y equals 0. So those are the key features of our sine curve. If we want to look at cos, we do the same thing. We can look at our unit circle to get those answers, or we can just plug it into a calculator. Cos of 0 is 1, cos 90 is 0, negative 1, 0, and 1. So if we want to plot cos on the same set of axes, we start at 1, and then at 90 we're 0, negative 1, 0, and 1. So that's what our cosine curve looks like. So red is our graph of cos x, and green is our sine x. And cos has the same key features, so an amplitude of 1, a period of 360 degrees, and an equation of axis of y equals 0. So those are our parent functions, we call them, our base functions, and now we're going to look at transforming them. Okay, so we're back to this situation, A, K, D, and C, that we've done a number of times already with a whole bunch of different functions. Sine or cos can be inserted. Okay, so first let's deal with A and C. Those values are things that will affect your y values. So A is our vertical stretch or compression, and if A is negative, we've got a reflection in the x-axis. So that's what A is doing to our graph. Another really important thing A does is it tells us our amplitude. So our amplitude is actually equal to whatever A is. So that's a key feature. And then the other thing that's affecting our y values for transformations is C. So C is our vertical translation, so it's shifting our graph up and down. And something C does is the equation of axis is actually y is equal to C. So whatever C is, that's going to tell you where the middle of your graph is. Okay, and then if we look at K and D, I think those are the trickier ones. So K is the trickiest of all. And K is going to be our horizontal stretch or compression. And remember, just to note, it's always opposite. So if K is a half, it's actually a stretch. And it's always by a factor of 1 over K. And then if k is negative, we have a reflection in the y-axis. x-axis. And then for D, that's just going to be our horizontal translation, so it's going to shift our graph left and right. Okay, and then something K does that I forgot to write here is it affects our period. So normally the period of sine and cos is 360 degrees, but if we do have a K value, that's going to compress or stretch our period, so we just divide 360 by K to figure out what the period will be. Okay, so let's try a transformation. Okay, say we wanted to graph y equals 2 cos x minus 1. Okay, so if we had to describe those transformations, we've got a vertical stretch by 2, and then over here we've got a c value, so that's going to shift our graph down 1. If we wanted to explain our key features, I know our graph is going to have an amplitude of 2, because A is 2. It's going to have a period of 360 still, because there's no K value, and it's going to have an equation of axis at y equals negative 1, so that's what's. So if we want to graph it, negative 1 is going to be the middle of our graph, kind of. Our amplitude is 2. I know my graph is going to go as high as 1 and as low as negative 3 because it has an amplitude of 2. So I'm going to have an axis at 1 and a minimum at negative 3. It's not shifting left or right. It's really just stretching by 2 and shifting down 1. So my original cos graph, it originally was, actually let me just draw my original on here. So my original went here, 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 and here. So that's my original cos graph. And now I'm going to graph my stretch and shift. So if I normally have a point at 0, 1, that's going to get stretched by 2, so that'll put it at 2, and then it's going to get moved down 1. So it's actually back where it started. Okay, then I have a point here at 90 and 0. So 0 times 2 is still 0, so the stretch won't affect that, and it's just going to get shifted down 1. Okay, here I'm at 180 and negative 1. So negative 1 times 2 is negative 2, and then it's going to move down 1, so negative 3. So pretty much just from like these 3 points right here, I can see exactly what's going to happen next. I can see my next value is going to be here. And then I'm going to go through back up at 1. So that's going to be one period of my cosine graph, and if I want to extend it to go the other way, I know I'm going to be there, down here, this one's going to go that way. So that's my transformed function. It's got amplitude of 2, equation of axis at negative 1, and it still has the same period. Okay, let's try graphing y equals sine, actually let's do a reflection. So let's do negative sine 2x. Okay, so the negative here is going to be a reflection in the x-axis. It's going to affect all my y values. So if I normally have a y value up here, a reflection in the x-axis is going to make that y value down here. So if my y value was 2, now it's going to be negative 2. And then this 2, that's our k value, so that's going to be a horizontal compression by a factor of a half, 1 over k. So if I had to talk about my key features, my amplitude is still going to be 1. I don't really care about the negatives, so amplitude of 1. My period is going to change, so instead of being 360 degrees, I have to divide that by k. So my period is actually just 180 degrees. And my equation of axis is staying the same. It's going to be y equals 0. So I don't have this. Okay, so if I wanted to graph this, okay, so Okay, so let's just do a quick sketch of our original function of sine. So it's 0, 0, 90 and 1, 180, 0, 270, negative 1, 360 and 0. So there's our original sine curve like that. So now if we're going to graph our transformation, okay, so let's start at 0, 0. So the reflection's not going to be affected, and the horizontal compression by half's also not affected, so we're still there. Okay, 90 and 1. So instead of 1, we're going to be down at negative 1, since I have a reflection. And then also, my x value is getting cut in half, so I'm going to be over here at 45. So this guy is taking my x values and multiplying them by a half. Okay, so my next point's 180 and 0. So 180 is not getting, the reflection's not going to do anything, but my x value is going to get cut in half. So it's actually going to be over here at 90. Okay, then 270 and negative 1. So that's going to pop up to 1. And 270 is going to get cut in half to 135, which is over here. Okay, and then 360, I already know that's going to get cut in half to 180. So there's a full cycle of my sine graph, a full period. So it's heading the opposite direction, and it's going twice as fast. So it just took 180 degrees to do one cycle instead of 360. And I can keep going if I want to. So I know it's like moving over half the distance here. So then I'll be at 270, and then here, and then 360. So it'll complete a whole other cycle. There we go. There's my graph of negative sine 2x. Okay, this video is really long, but I'll just do one more in case you need another example of, let's do y equals sine x plus 45 degrees minus 1. Okay, so that's going to be a shift left 45 degrees, and this one's going to be down 1. So my amplitude is still 1. My equation of axis is y equals negative 1. And my period is still 360. Okay, so sketch that at 90, 180, 270, and 360. Actually. -1, -2. Okay, so if I wanted to graph this function, normally I'm starting at 0, 0 for sine, but this time I'm actually going to shift left 45 and down 1. So I'll be right there. Then I'm normally at 90 and 1, but I'm going to shift left 45 and down 1. Then normally I'm at 180 and 0, but I'm going to shift left 45 and down 1. Then normally I'm at 270 and negative 1, but I'm going to shift left 45 and down 1. Then I'm normally at 360 and 0, but I'm going to shift left 45 and down 1. So there's my new sine curve. So it's like the exact same shape, it just got shifted. And that's it.